Hello Beyond the Five students, my name is Angel Jimenez and welcome to Unit 7.8, Representations of Equilibrium. By the end of today's lecture, you should be able to represent a system undergoing a reversible reaction with a particulate model. Let's get right into today's lecture. So, the first thing you might be wondering is, what the hell is a particulate model? Well, they look like this. Let me walk through what's happening in this model, in this picture. So obviously on the bottom we have the time, and we can see that in the first three pictures the time is increasing by 100 seconds. So while this reaction is undergoing, it's changing throughout the three pictures. In the first picture we can see this double circle molecule. We can see a molecule with a big circle and two little circles, and there's three of each. So this is probably the reaction before it even reacted to form any product. This is probably just the reactants being placed in a container of some sort. The second picture, which occurs at 200 seconds, shows us a new molecule. It is a big circle with four little circles. This is probably the beginnings of the equilibrium reaction. And we can see that the two little circles have gone down from 3 to 1, and now we have two normal circles. And now we have one big circle with two little circles. At 300 seconds, we have another big circle with four little circles. We've gone down back to one big circle with two little circles, and still two little circles. So now that we can see this reaction, alright, so let me ask you a question. So if I asked you to draw a picture, if I gave you a blank square and asked you to draw a picture of the system at equilibrium somewhere after 300 seconds, but before 400 seconds, which is the next, if we're going up by 100 seconds, we can assume the next picture will be at 400 seconds, what would your picture look like? Think about it, maybe even draw it out. Here is what it should look like. Now you'll notice that the 400 second picture is exactly like the 300 second picture, and there's a reason for that. When we say a system is at equilibrium, that means that the concentration on both the reactant and the product side is constant. It doesn't have to be the same, it just has to remain constant. So if we reach equilibrium somewhere after 300 seconds, but before 400 seconds, theoretically, the picture at the 300 second mark is going to be the exact same as the picture at the 400 second mark, because the concentrations are going to remain constant. Now, if you didn't get that, don't blame yourself. Just keep it in mind and remember it for when you do have to, when that question is asked to you in the future. Now, let's work with a slightly different model, with a different scenario. Here, we have a different amount of concentrations of each of the three different molecules. You know, you have two of the two circles, we have two of the big circle, two little circles, and one of the big circle, four little circles. Now, let's say I took the volume of that container, that whatever it's in, and I decreased it by 1/2, and I smushed everything down. So now it went from 1/2 of the original volume. So now we have the exact same particles, the exact same molecules, in just 1/2 of that volume. And now let's say I asked you to draw the picture of the next step of the reaction, or the reaction at equilibrium. What would your picture look like? Well, let's think about this. We already know that the only change that we have is that the volume has been reduced. Whenever the volume is reduced, and we're dealing with gas, and so let's assume this is gas, the side with the less number of moles is going to be favored than the side with the more number of moles. And so if we assume that those two reactants are coming together, which it looks like they are, to form that product, which is the big circle with four little circles, we can assume that there are more moles of gas on the reactant side than the product side, meaning that more product is going to be formed in the next step of the reaction. And if we look at the picture for 300 seconds, or the next step of the reaction, we can see that that is correct, and that more product was formed because that side was favored by the equilibrium. Now I know this lecture might have been a bit confusing than the other ones. I tried to make it as clear as possible. Please do not hesitate to contact me if you have any questions. You can reach me through Discord or email, and I will try to get back to you as soon as possible. I do hope that you found some use out of today's lecture, and I wish you all good luck on your studies.